Let's now look at some effects of content of this highly contextualized and working memory intensive native deductive capacity that we've illustrated to this point. So let's start with a bias that's associated with conditional reasoning. This bias was first identified by a Stanford researcher named Evans in 1982, and it's called the negative conclusion bias. So he gave his students an argument, and he said, tell me whether or not this argument is a good or a bad deductive argument. So here's our argument. If the triangle is yellow, then the ball is blue. The ball is not blue. Conclusion, therefore, the triangle is not yellow. So you can stop the video for a second if you want, think about it, decide whether or not you think that is a good deductive argument or a bad deductive argument. Now look at a second argument. If the triangle is not yellow, then the ball is blue. The ball is not blue, therefore the triangle is yellow. So again, you can stop the video for a second, think about it, decide whether or not you think this is a good argument. Now, you might have noticed, but lots of students may not, that these arguments are really the same basic argument. It's so common, this argument, that it's got a Latin name. It's called modus tollens. Modus tollens are conditional arguments where one premise is a conditional statement. If the triangle is yellow, then the ball is blue. It relates the truth of what's called the antecedent of the conditional to the truth of the consequent. It relates this statement's being true to this statement's being true, asserting whenever this statement is true, this statement is also true. Our second premise says this statement isn't true. This second part isn't true, and therefore if our conditional statement is true, the antecedent can't be true either. It can't be the case that the triangle is yellow. These are both the same argument. The difference just is the negation in the antecedent, in the first part of the second conditional statement here. And what Evans discovered is by asserting that negation into the antecedent, so that the conclusion in effect is the triangle is not yellow, or it's not the case that the triangle is not yellow. That little bit of introduced complexity, that single negation and getting rid of it in evaluating the argument, that was sufficient to lower the correct responses from 75% correct to 45% among his students at Stanford. Later on, Evans, in researching this phenomenon, came to call this the double negation effect. And so what he said is, in arguments like this, where the antecedent has a negation, we are worse at evaluating the resultant argument because that addition of a negation to a negation, where the two negations effectively knock each other out. So a double negative is always an affirmative. When it's not the case that it's not the case that B, it's going to be the case that B. That little bit of complexity was all the complexity that was needed in order to undermine student performance by a full 30%. Our next example is an example of the interaction of content and context. So here's an argument. Some animals are mammals. Some animals are dogs. Some mammals are dogs. Now just take a second, maybe stop the video, think about it, and decide whether or not you think this is a good argument. Now chances are you probably found this to be a good argument. This argument is in fact an example of what's called belief bias. Our conclusion is believable. Because our conclusion is believable, we are psychologically more likely, using our native deductive capacity, to think that the argument is a good argument, regardless of whether or not it actually is. So our bias about the believability of the conclusion affects our evaluation of the entire argument, whether or not the argument in fact gives us good reasons for believing that the conclusion is true. Now, in both of these cases, a bias in reasoning is just a systematic influence of some logically irrelevant feature to the task of inference. We can see that this is a bad argument by putting in different content. So if we change the argument's content without changing the relationships in the argument, we can see that the truth of the initial statements won't guarantee the truth of the conclusion. So if we say some animals are cats, some animals are dogs, therefore some cats are dogs, the relationships in the second argument are exactly the same as the relationships in the first, but it's clear that the premises of the first two statements are true, but the third statement is not true. And so this argument, the underlying structure, relates the content in a way that doesn't preserve truth through that inferential transformation. Now, in our next lecture module, we'll switch gears and turn our attention to that second category of inference strategies in System 1, those context-dependent inference strategies.